So what we're starting today, or what we're doing today, is finishing up chapter 6.6. And this is the last section we're covering in chapter 6. And it's solving inequalities. And the way we solve inequalities is going to be the exact same way we solve equations. We want one term on either side, so we need the 3 to the x by itself, which it is. Numbers on the other side, 20. And once we get this here, we want to get the variable out of the log, or out of the exponent. And to do that, we have to apply logs to both sides. And because the base is not e, we're going to use log. And what do we want the base of this log to be? 3. Because log base 3 is going to work very nicely for this problem. Bless you. Bless you. Questions on this here before we continue? Now the reason we applied a log is because our power property says we can move that exponent to the front. So we move x to the front, telling us that we have log x times log base 3 of 3 is less than log base 3 of 20. Questions on this here? What is log base 3 of 3? 1. For simplicity's sake, really, I'm just going to draw a line through it with an arrow saying, hey, this is 1. That's why we use log base 3 of 3, yes? So it means the left-hand side is x times 1, or just 1x, or x, telling us that x is less than log base 3 of 20. Now we need to get x by itself. It is. So the solution for this is that x is less than log base 3 of 20. And we can leave it in this form here if we want. Because there are probably specific rounding rules for inequality, so we actually get a true statement. And if we wanted to plug it in, log base 3 of 20, already have it typed in, is 2.726833028. So that would be our solution. Or we can just leave it as this here. Questions on this so far? Questions on anything we've done so far? Let's look at the next one. E to the x is less than 2. Luckily for us, our e term is by itself. And we do have everything else on the other side. Now we need to apply a log to both sides to get that variable out of the exponent. What log would we apply to both sides? Natural log, because the base is e. So the first thing we would do is take that exponent and move it from the exponent to in front of the log, telling us that we have x times the natural log of e is less than the natural log of 2. And what is the natural log of e? Natural log of e is just 1. Really telling me that x is less than the natural log of 2. I didn't say it on the last one, but this one here, since the variables start out in an exponent, we don't have restrictions. We can put whatever number we want in an exponent. We can put natural numbers, rational, irrational, positive, negative. We can have any number we want in an exponent. So when we're solving, when x starts out in an exponent, we don't have restrictions on our solution. It can be whatever we want. So x is just less than the natural log of 2. Questions on this here? Are you ready for the next one? 10 to the 2x minus 6 is greater than 3. If there's anything with our base, we need to get it by itself. So if it had been 2 times our 10 to the 2x minus 6, we would need to divide both sides by 2. If we had 3 added to it, we'd have to subtract 3. If we had a number here or something added here, we need to move those to the other side before we can apply a log. But in this case here, our base 10 is already by itself, yes? So we need to apply a log to both sides. And because the base is not e, we would use log, our log. What base do we want? 10, yes? It's just log. I don't have to write it because it's understood to be 10. And the reason we do this is so that we can move the exponent to the front. We can get that variable out of the exponent. Telling us that 2x minus 6 times log of 10 is greater than log of 3. Well, what is log of 10? 1. That's why we picked log base 10, yes? We picked it so that this would simplify to 1. Leaving us with 2x minus 6 is greater than log of 3. Questions on this here? Is x by itself? So what do we need to do first? Yeah. Add 6 to both sides, because our negative 6 plus 6 would cancel. Telling us that 2x is greater than log of 3 plus 6. We cannot add the 3 and the 6 because the 3 is inside the logarithm and the 6 is not. What do we do next? Divide both sides by what? 2. Because 2x divided by 2 is x is greater than log of 3 plus 6 over 2, yes? What's next? Yeah, that's it. And because the variable started out in an exponent, we don't have restrictions, we don't have values of x, we have to exclude from it. So we're saying x is greater than log of 3 plus 6 over 2. If I wanted to know what that value was, I can do log of 3 plus 6 all over 2. So it's 3.238560627, or 3.239. And our starting equation was 10 to the 2 times 3.239 minus 6, I believe. 10 to the 2x minus 6. 10 to the 2 times our 3.293, that's our value we're using for x, minus 6, and we said this should be greater than what? 3. Do we have a value bigger than 3? So that works. So it's telling us that this log of 3 plus 6 divided by 2 is our answer. And we'll leave it there. Because we could get the decimal approximation, but again, there are rules with, and probably and most likely rules with how we round dealing with inequalities. Because as we just rounded, if we were to round 3.238, it would be 3.239, which is actually a solution. So there are some technicalities to it. Does that make sense? Because I'd almost just round down and say 2.238, or just leave it as 8 instead of rounding up to 9, just to guarantee that it is grerer than it. It has to be bigger than it. But Best case is just leave it as this here. Questions on this here? Questions on any of this so far? Next what we're looking at is logarithms. Now even though it's not written, we know that those parentheses have to be just around the x. Now because we are talking about logarithms, it's starting off in a logarithm. We know that we will have restrictions. And what's inside the logarithm, which in our case is just x, has to be greater than 0. Because I cannot take a logarithm of 0 or negatives. So any value of x that would make what's inside the logarithm be 0 or negative has to be removed. Now we have to be a little more careful with inequalities because an inequality is not just a value of x. It is a set of values. We have more than one. So we do have to be careful. Now that we figured out what x cannot be, we can go about solving this here. And for this here, is the log already by itself? Yes. Now we need to put both sides to a base that is the same as the base of the log. And what is the base of our log? 10. Because it's not written, the base is understood to be 10. So we have put both sides to the base 10, because 10 to the log base 10 would cancel, leaving us with what's inside. Now we could at this point say that x is less than or equal to 10 squared. Is 10 squared a nice number? What is 10 squared? So our solution at this point says that x is less than or equal to 100, yes? Now before we can be done and say this is the answer, we need to check our restrictions. Our restriction said that x has to be greater than 0, yes? Would 0 be a restriction for this here? Is 0 less than, or 0 greater than 0? No, because that's one of the restriction values, yes? I'm going to take that value and plug it in. Is 0 less than or equal to 100? This is true, yes? And what that's telling me is that my restriction values, the values that x cannot be, are included in my solution set. We have to remove them. Be ready to remove them. 0 is less than x is less than or equal to 100. We're just taking that statement that we got for the restriction and sticking it on there. Now we do need to make sure that the inequality arrow is pointing in the correct direction. That is it indeed less than 0 is less than x is greater than 0. We have it pointing in the right direction, telling us that the values of x have to be bigger than 0 and less than or equal to 100. And that's it. Questions on this here? Funny enough, if this had been x is greater than 100 or greater than or equal to 100, we don't need the restriction because 0 is not greater than 100. Those values of x that would cause an issue are not included in the solution set, so we don't have to remove them. They've already been removed. Questions on this here? Be ready for the next one. X is inside a logarithm. So what's inside the logarithm has to be greater than 0, yes? What is our expression inside this logarithm? So what has to be greater than 0? Anything else? Remember when they don't put parentheses, that plus 9 is outside. If they wanted it to be x plus 9 inside the logarithm, it would have been written as this here. So really the only thing inside the log is just x. So it's telling us x has to be greater than 0. There's no solving we have to do. It's already finished. X has to be greater than 0. Questions on this here? Is the log by itself? No, what do we need to do first? Subtract 9 from both sides. Does 9 minus 9 is 0? Telling us that log of x is less than 36. Now is the log by itself. Yeah, and at this point, we're not caring about what's inside the parentheses. We want to make sure there's nothing being added to that log or nothing being multiplied in front of that log. But now that we're here, we can put both sides to the base of 10. And we do this because 10 to the log of x is going to simplify to x is less than 10 to the 36th. Is that a nice number? No, so what are we going to do? 10 to the 36th power, because really that's 1 and 36 zeros. That number is massive. So leave it as this here. Again, our variable started out inside of a log, yes? So what's inside that logarithm cannot be 0 or negative. It has to satisfy this here, yes? Again, easiest way, or I think a nice way to check, is I just plug 0 in for x. I plug one of my restriction values. Now, yes, we don't have to use 0. I could use negative 10, because negative 10 is not greater than 0. It is a part of the restrictions. Is negative 10 less than 10 to the 36th? Yes. So that means those restriction values are a part of our solution. We have to remove them and just say 0 is less than x is less than 10 to the 36. Because if we leave it there, negative 10 is indeed less than 10 to the 36. So according to our original statement, it is a solution, it is a value that should work. But we know because of logarithms, it would make what's inside that logarithm not work. Questions? How we find the restrictions? So the restriction, so we know, I'm going to clear this out, because there's parentheses around here, yes? I cannot take log of 0, yes? Because log of 0 doesn't work. If I had, say, or I just picked negative 10, I'll use it again, I cannot take log of negative 10. I can't take log of a negative number. So, what we did at the start, back all the way up here, is we started off by saying what's inside the log, which is just x, has to be greater than 0. Because if it's equal to 0, I can't take log of 0. If it's less than 0, I'm taking log of a negative number. It doesn't work either, so I'm removing those. I'm saying that x cannot be less than 0. X has to be, our solutions have to be greater than 0. Does that make sense where we got that? So we got that, we just set it there. This is a reminder to myself, x has to be bigger than 0. Then we went through and solved and found, according to our solving step, x is less than 10 to the 36th power, yes? And what we did at this point is I went back and checked my restrictions, saying x has to be greater than 0, yes? So just to make sure that we don't have restrictions, any of these values that would make this false, showing up in here, is I pick one. So give me a value that would not be greater than 0. Yep. Negative 1. So then I can check and see, is negative 1 less than 10 to the 36th power? Well, yes. And what that's telling me is if I leave this statement as it is, I do have all the solutions that work, but then I also have all of these solutions that don't work, because I can't have negative 1. I know that because of logarithms. But as this statement stands, negative 1 is a solution. We can't have that. So what we do is we take that restriction statement and slap it on there saying 0 has to be greater than x. Does that make sense? And if it had been, say, 0 is, I'm just going to change it for the time being, x has to be greater than 9. Well, instead of putting 0 here, we're going to put 9. 9 is less than x is less than 10 to the 36. Make sense? But that's all it's doing is we're trying to remove those values that would cause what's inside the log to be negative. Questions on this here? That's a good question. Get ready for the next one. Now this one here, it might be helpful to where we just don't have x is less than, or x has to be greater than 0, yes? So let's fix this. Let's put parentheses around the x minus 1. Let's say that's all inside this log. That way we get a little diversity into our statement. Restrictions. Now what's inside is x minus 1, yes? And it has to be greater than 0, because if it has values less than 0 or is equal to 0, those do not work. We have to throw them out. And unlike the last few, we're actually going to have to solve this. And to do that, we can add 1 to both sides, telling me x has to be greater than 1. If x is not greater than 1, we have to throw those solutions out. Questions on this here? Okay. Before we apply a base to both sides, is our natural log by itself? No, we have what? The 2 in front. So how would we get rid of the 2? We're going to divide both sides by 2. And that would tell me that the natural log of x minus 1 is greater than 2. Yes? Is the natural log by itself? Yes. So now we can put both sides to the base of. And we do this because e to the ln will simplify, leaving us with x minus 1 is greater than e squared, yes? Is x by itself. No, it's out of the exponent, but it's not by itself. So the last thing we need to do is add 1 to both sides. These would cancel, telling us x is greater than e squared plus 1. Questions on this here? The only way we'd have to flip that inequality sign is if we multiply or divide by a negative, or we start dealing with some even exponents. But before we can say we're done, we do have to check our restrictions, yes? Can someone give me a value that would be a part of our restrictions that wouldn't work? 0, because 0 would be a restriction, yes? Is 0 greater than e squared plus 1? What is e squared plus 1? Well, e squared plus 1 is 8.389. Is 8.3, is 0 greater than that? So this is not true, which means are our restrictions included in our solution? Well, no, because the values that would make what's inside this logarithm be negative or 0 do not make x greater than e squared plus 1 be true, yes? So those restrictions are not included in the solution set. So do I need to add this? No, I don't have to remove them. They're already gone. So this here is just saying x is greater than e squared plus 1. Because the restrictions are not included in our solution, we don't have to remove them. The last two that we did, the restrictions were included, so we had to remove them. We had to get rid of them. Questions on any of this here? Now we'll do one more. I'm going to modify this a little bit just for time's sake. I want to move this square and change it to x plus 4. Doesn't do a whole lot. It does, there's like one or two steps at the end that do differ because of that, but for the most part, not that big a deal. Now the big thing is that we do have to get e by its, so what can we do first? Subtract 3. I always look for addition and subtraction to move terms first before we do anything else. Because on the left-hand side is going to be 5e to the x plus 4 is less than 300. Now, we don't have to look at restrictions for this here because the variable started in an exponent, not inside a log. What would we do next? By 5. We're going to divide both sides by 5. Telling me e to the x plus 4 is less than 6. Is our base e by itself? Yeah, I mean, we have the x plus 4 in the exponent, but that's in the exponent. I want to make sure that base is by itself. And it is indeed. And since that e is by itself, we're going to do what? Apply the natural log to both sides. We need to get that variable out of the exponent. Because logarithms will let me move a power out of the exponent to the front of the log, telling me that the natural log of e to the x plus 4 is equivalent to x plus 4 times the natural log of e. And the reason we chose natural log with our base e is because the natural log of e is what? 1. So really this here reduces to 1. And 1 times x plus 4 is x plus 4. And last but not least, we need to get x by itself, so we're going to minus 4. Minus x is less than the natural log of 60 minus 4. If there had been a number multiplied with x, we would divide both sides by that number. And if we multiply or divide by negative, we would flip the sign. Questions on this here? The squared x squared just gives us a little bit funky case with square roots and inequalities because we do have to flip it for the negative case. But for the most part, there are some other funky ones, some particular cases. We're not going to worry about them at this point. They're not going to show up on the homework.